All right, welcome to section 8.1. Chapter 8, we're going to be talking about polynomials. It's actually quite a large chapter. We're going to do the first 4 sections and then we'll test on those and then we'll move on to the rest. So first of all, we need to talk about polynomials, binomials, and trinomials. We talked about monomials a chapter or 2 ago. Anything that we multiply numbers and or variables, so like 3x would be a monomial. Well, a polynomial, the prefix poly means many. So a polynomial is any monomial or the sum of them. So like a 3x plus 4y minus 6z. That would be the sum of. Remember, sum means add, but subtracting is just adding a negative. So we can have pluses or minuses. Polynomial will be monomials separated by pluses or minuses. A binomial, that prefix means 2, like a bicycle. So it's a sum of 2 monomials specifically. And a trinomial, tri means 3, like a tricycle. So a trinomial is a sum of 3 monomials exactly. Poly is any number. Binomials specifically 2 monomials, trinomials specifically 3 monomials. So these first practice, identify if it's a polynomial and explain, and identify if it is a monomial, a binomial, or a trinomial. So 6 minus 4, if we just look at it, remember constants, numbers, can be monomials. So this is a yes. As it is written, there is 2 parts to it separated by a minus. Or we could say, remember, it's like 6 plus a negative 4. So that is a binomial. It has 2 terms. If we're going to be technical and do the math and say that's equal to 2, it'd still be a yes. But 2 is a monomial. B right next to it, 14d plus 19e squared, all over 5d to the 4th. Is that a polynomial? Do we ever have division? Remember we looked at when we talked about monomials, did we have variables in the denominator? Nope. So no, we'll put a variable in the denominator. Letter C, I've got an x squared plus a 2xy minus 7. Well, that one, there's nothing wrong with it. So this is, yes, a polynomial. I see 1, 2, 3 monomials. So therefore, we've got ourselves a trinomial. Being able to identify these is going to be important simply because I'm going to use this terminology a lot. Letter D, I've got a 26b to the 5th power. Remember, that's just numbers and variables being multiplied together. We could write it out the long way if we wanted to. So yes, this is only one term, so it's a monomial. Remember, one term can be multiplied, things multiplied together. Letter E, is a plain old y a polynomial? Yes. And how many terms are there? In other words, is it a monomial, binomial, or trinomial? That one's a monomial. One term, y is all on its lonesome. Same with D, 26b to the 5th is all by its lonesome, even though it has more parts to it. And last but not least, F, negative 5b to the 5th minus 6. Nothing wrong with this guy, so yes, it is a polynomial. I see 1, a negative 5b to the 5th, and 2, a negative 6. So a binomial for that one. Right, so identifying how many terms there are. So now let's talk about degrees. There's 2 separate things to look at, degree of a monomial and degree of a polynomial. So the degree of a monomial is when you add up all your exponents on the variables. Sum of all the exponents on the variables. So if I had 3x cubed y, well, I've got a 3 for the exponent on the x, plus, so what's the exponent on the y if there isn't one? So the degree for that would be 4. So sum of the variables, or sum of the exponents on the variables. The degree of the polynomial, basically you do the same thing, and you choose the largest one. So the degree of a polynomial is the largest degree of any one monomial. So if I'm going to reuse that 3x to the third y, and then I'm going to add a 4x squared y. So we just decided the degree of this is 4, because 3 plus 1. The degree of this is 2 plus 1, or 3. So the degree of this polynomial is 4. Pick the biggest one. Pick largest degree. Don't add them all together. Do each term separately of that polynomial. And there is information in the book. It talks about how you name polynomial based on their degrees. If there isn't a variable, your degree is 0, because just a 3, remember we're taking the exponents on the variables. If it's a 1, it's a linear equation. If it's a 2, it's a quadratic. I didn't want to throw too much in there, so let's just know that polynomials are based on their degree, or their highest degree of any one monomial in that polynomial. And we'll talk about that. We're going to talk about quadratics and things. So first of all, I got a little box here. First thing we have to decide is the given example a polynomial, yes or no? If yes, what's the degree, and then how many terms does it have? So 8y to the 4th, is that a polynomial? I'd say yes. What's the degree? What's the sum of all the exponents on the variables? Remember, the 8 doesn't count because the 8 doesn't have an exponent. It's a number. We only care about exponents on variables. So I'm going to say the degree is 4. And how many terms are there for an 8y to the 4th? That's just a lonely monomial. Even though it's got 8 times y times y times y times y, it's one term altogether. So multiplying all groups together. Letter B is sneaky. Watch carefully. What is wrong or unusual about 9a to the negative 2 minus 7b? Well, we all know we don't like a negative exponent. That really would be 9 over a to the second power. And then we're talking about variables in the denominator. So this guy is not a polynomial, which means we're not going to talk about degrees or how many terms there are. Letter C, I've got a negative 4x squared y squared plus 3x squared. First of all, is that a polynomial? I would say yes. There's nothing wrong with it. The degree, if it's a polynomial, remember we're going to pick the largest degree. So the degree of this first piece right here, add up your exponents on your variables. So 2 plus 2 equals 4. The degree of a 3x squared, we only have a 2, so we're going to pick the largest one of those two. The degree of the first term is 4, the degree of the second term is 2, so 4 is our answer. And then I kind of said what kind of polynomial it was, just because I mentioned that we've got 2 terms, so I'm going to say that that is a binomial. 2 terms in it. The first term is a negative 4x squared y squared. The second term is a 3x squared, separated by a plus or a minus. And the last one, 9x squared minus 2x minus 4. First of all, is that a polynomial? I don't see anything wrong with it, so that's a big yes to me. The degree, well, the degree of this first term is a 2. The degree of a negative 2x is a 1. Remember, there's a 1 on that x if there isn't anything. The degree of a negative 4 is 0 because there isn't even a variable. So that means my highest out of those 3, my degree will be 2. And then we looked at 3 different pieces to see what the degree was. So that's going to be a trinomial, 3 pieces. Okay. So now let's talk about standard form. We used to call this descending order, kind of change the terminology. But standard form, if you think about descending, it will make sense. Arrange your terms from the largest to the smallest degree. Biggest exponents first, smallest or no exponents last. And you're always looking at the variable, not at the numbers. So descending, if you descend the stairs, you're walking down them. We want the highest degree first, lowest degree last. And it's also going to ask you about the leading coefficient. So the leading coefficient is the number in front of the term with the largest degree. The number or coefficient of the term with the largest degree. Remember, coefficient is the number out in front of that variable. So I gave you a little example here. 4x cubed minus 5x squared plus 2x plus 7. So I've got myself 4 terms, it looks to me. When I'm looking at standard form, notice the variables on my x. I've got a 3, and then I've got a 2, and then I've got a 1 or no variable, and then I've got no x's at all. And the 3 is my degree. It's my highest exponent. That 4 out in front is my leading coefficient. That's the number in front of the term with the highest degree. So if you notice the practice problems, it says write each polynomial in standard form. Identify the leading coefficient. So once I put it in standard form, I'm just looking for the number in front of the highest or the first term. So practice A and B down here. 16 plus 14x to the third plus 2x. So what is, I've got only x's. What's my highest degree? Right, I've got a 3, so that means that my 14x to the third power has to go first. Then my next highest exponent of x, so plus 2x. And then that 16 just gets stuck on the end out there because it doesn't have an exponent or a variable. So it goes first. So here's standard form, 14x to the third plus 2x plus 16. Oh, excuse me on that phone. And then my 14 is my lead coefficient. I'm going to abbreviate it LC because lead coefficient is too long to write. Right? So we put them in order, and then we figure out what is the lead coefficient. It's easier to do it in that order. So for B, I've got a 5y minus 6 plus 3y squared minus y to the third. I did this one on purpose. First of all, we've only got y's. So it's my highest exponent of y, right? And make sure you take that sign. My first term, when I write this in standard form, is negative y to the third. The sign in front of that variable with its exponent is the sign of that term. So don't just leave that negative out there. After the negative y cubed, I've got a squared, and that's a plus 3y squared. After that, I've got just a 5y. If there's no sign in front of 5y, what is it? Right, it's a plus 5y. And then that minus 6, I didn't do anything with it, so I'm just going to stick it on the end because it doesn't have any y's with powers at all. So my lead coefficient, I'm going to write this 14 over here. What's my lead coefficient for this one? What's the number out in front of my y to the third power? I did this one because I wanted to make sure you catch this. It's negative 1. Remember, if there isn't a number, it's a 1. And the number in front of the y cubed is then negative 1. Right? So lots of terminology to get out of the way and talk about. Now that we've done that, now we can actually talk about what the section title is, which is adding and subtracting polynomials. So first of all, if you've got a minus in between your parentheses, distribute it. Just take care of it totally. That way you don't have to worry about what's the sign. Combine like terms. In other words, you can only put x squared together with x squareds, or y to the fifth together with other y to the fifths. So you cannot combine an x squared and an x to the third because they are not like terms. You have to just write them separately. I do this just to make sure that I see what or do what I need to do. Cross out the terms after combining them. And write your answer in standard form. So I do this automatically. I say to myself, all right, I'm looking for like terms, and here's the highest exponent, because I might as well take care of everything at once instead of having to rewrite it after. So standard form, remember, look for your highest power of x first, or highest power. I'll put highest degree first. All right, so let's run through a couple examples. Let's do 1 and 3. Problem number 1, I've got a 6n to the 4th minus 4 plus, and in parentheses, 9 minus 2n to the 4th. Please notice 2 sets of parentheses, there's a plus sign in the middle. Guess what we're going to do if there's a plus sign in the middle? We're going to add like terms. We don't even have to distribute if it's a plus because it doesn't change anything. If we wanted to, we could just write this without parentheses, but you do not have to. Just make sure all your signs go together. When I do this, I usually box stuff. My highest power of n is n to the 4th. Notice I've got a 6n to the 4th, and don't forget the sign negative 2n to the 4th. When I combine those, I do the number math, and I keep the n to the 4th the same. So 6 plus a negative 2 will be 4n to the 4th. Notice I'm sneakily putting my standard form in there because that's my highest power and only power of n. So I'm not crossing them out, but I boxed them so that I can see. Then I've got a minus 4 and a plus 9, or negative 4 plus 9. So when I combine those two like terms, plain old numbers, I've got a 4n to the 4th plus 5. Everything in my original problem's been boxed or circled, accounted for, cross them out, whatever makes you see whether you have or haven't used it. So I wrote that in descending order, or standard form. I combined 2 pairs of like terms, and I didn't have to worry about that negative for subtracting. Number 3, however, I've got a negative in the middle, right? So look at my 2 sets of parentheses. I've got a subtract in the middle. Subtract tells me to use the distributive property. So in other words, I'm going to put a 1 in there, and I'm going to distribute. First parenthesis does not change at all, so I'm just going to rewrite 11 plus 4n to the 2nd. When I distribute negative 1 times 3, and negative 1 times a negative 6n squared, don't miss that sign, that becomes a plus 6n to the squared. So now, when I go ahead and combine like terms, my highest power of n, because I want to be sneaky and do 2 things at once, is n to the 2nd. I've got a plus 4n to the 2nd and a positive 6n to the 2nd. So what do I get when I combine those like terms? 10n to the 2nd. And then I've got myself an 11 minus 3, and that's a positive 8. So 10n squared plus 8 for problem number 3. So look for the sign in between the parentheses. That's really a big deal, because if you miss that minus, it's going to screw up your answer. Obviously, you're going to have all the wrong things when you combine like terms. All right, let's do this example, and then I'll get to the lesson summary. It says the measures of 2 sides of a triangle are given, 4x squared minus 3 and a 10x plus 7. If P is the perimeter given on the left-hand side, find the measure of the third side. Well, how do you find perimeter, right? Perimeter is when you add up all 3 sides of a triangle, but it's only giving us 2 sides. Do we have enough information to find the measure of the third side? If I add up these 2 guys and subtract it from the whole thing, won't I be left with that third side? So I'm going to add these 2 up. 4x squared minus 3 plus 10x plus 7. When I add these 2 guys together, I'm going to just ignore the parentheses since it's an adding in the middle. 4x squared is my highest power of x. There's nothing to combine it with, so I'm just going to bring it down. 10x to the first is my next. That's a positive. Nothing to combine that guy with, so I'm just going to bring it down. And then I've got a minus 3 and a plus 7. So I've got myself a positive or add 4 at the end. So that's 2 of the 3 sides of the triangle. If I know that they all add up to 10x squared minus 5x plus 16, I can finish this problem over here by subtracting. Notice I'm putting big parentheses with a minus in the middle. I'm going to do like I just did. Subtract equals distributive property. So I'm going to take that negative and multiply it, or remember it's like -1. So bring your first parenthesis down, nothing changes. 16 minus 4x to the second minus 10x and minus 4 when I distribute the -1 to all 3 things. So now let's look for like terms. I've got a 10x to the second and a minus 4x to the second. So hopefully you're thinking with me that that's a 6x to the second. I've got a minus 5x and a minus 10x, both negative. Go to your calculator if you need to, but I'm thinking that's a negative 15x. And last but not least, I've got a plus 16 and a minus 4. So I'm going to say that's plus 12. So my final answer is going to be 6x squared minus 15x plus 12. So it was a good practice for adding first and then subtracting from the whole perimeter. The whole perimeter, by the way, had to go first in my subtracting problem because that's the whole thing, and then we're going to take 2 parts away to find the third part. All right, we've reached the end. Lesson summary. Here's what I want to know from you. What to you is the most important thing to remember when you're adding or subtracting polynomials? What's the most important thing to remember? Maybe it's distributing that negative sign. Maybe it's looking for like terms and making sure you're combining. Maybe it's worrying about the exponents. Maybe it's about putting them in standard form or descending order. What's the most important thing to remember when adding or subtracting polynomials? Or what do you think might trick you? In practice problem, please do this subtraction problem. Got in one parenthesis 3x cubed plus 2x. A subtract in between, x squared plus 2x. So go ahead and do that problem. Have a great day. We'll see you next time.